Hi everyone and welcome back to the channel. In today's video, we're diving into a powerful concept in machine learning, federated learning, a method that allows models to train on data without that data ever leaving your device. We'll explore how it works, why it's a game changer for privacy, and where it's used in real-world applications. Federated learning is a machine learning technique where training happens on decentralized devices, like your phone or edge devices, instead of gathering all the data in one central place. This helps maintain privacy and comply with data regulations. The core concept is simple. Instead of sending data to a server, federated learning trains models on local devices and only shares model updates, not data. This keeps data private and secure. Traditional ML. In traditional machine learning, data from all sources is collected and stored centrally. This poses risks of data breaches, requires high bandwidth, and leads to heavy computational demands on a single server. In contrast, federated learning keeps data on each device. It trains models locally, sends only model updates, not raw data, and merges those updates into a central model. This improves security, reduces bandwidth usage, and lowers computing load on individual servers. Distributed computing principle in federated learning 1. Decentralization. Training takes place on multiple client devices using their own local data. This approach ensures data privacy by keeping data on the originating device. 2. Coordination via central server. A central server collects model weights from each device. It aggregates these updates to build a shared global model. Third, fault-tolerant system. The system remains functional even if one or more devices go offline. Other devices continue training and contributing to the global model. How federated learning works: 1. Initialization. A global model is shared to all client devices. The model starts with common parameters set by the central server. 2. Local training. Each device trains the model using its own private data. Training is done independently, so raw data never leaves the device. 3. Aggregation. Devices send their model updates, weights, to a central server. Only the learned parameters are shared, not the underlying data. 4. Global update. The central server combines the received weights to update the global model. This ensures the model benefits from all devices learning. 5. Iteration. The process repeats until the model achieves desired accuracy. Each round helps the model get smarter while maintaining data privacy. System architecture. At the top, there's one central server. This server's job is to coordinate the training of one big AI model, the global model. At the bottom, you see multiple phones, or devices. Each one has its own local AI model. These devices train the AI model on their own data, like photos, messages, or health records, without sending that private data anywhere. Once training is done, the devices send only the learned updates, not the data, to the central server. The server combines these updates and makes the global model better. Then it sends the improved model back to the devices, and the process repeats. Why this is useful: the system is strong and reliable. Even if one device turns off or goes offline, the rest can keep working just fine. It helps train better models using real-world data from many sources, making the AI smarter and more accurate over time. Advantages of federated learning: 1. Privacy. Preserving raw data stays on your device, so sensitive information like personal messages or health records is never shared. Reduces the risk of data breaches since nothing leaves the user's device. Helps build user trust by keeping personal information secure. 2. Scalability. Supports millions of devices at once, from phones to IoT devices. Each new device brings fresh data, making the model smarter. 3. Low compute load. Ideal for smartphones and edge devices with limited power. Allows training to happen in the background without affecting performance. 4. Bandwidth efficiency. Great for areas with limited or expensive internet. Reduces network congestion, making communication faster. 5. Regulatory compliance. Makes it easier for companies to meet legal data protection standards. Useful in industries like healthcare and finance, where strict rules apply. Challenges in federated learning: 1. Communication overhead. Since model updates are frequently sent between devices and the server, it can put pressure on network resources. Requires stable internet connections, which may not always be available. Increased power consumption on mobile devices due to constant syncing. Slower training times if the network is weak or congested. Second, system heterogeneity. Devices differ in terms of hardware, software, and battery life, making it hard to coordinate training. Slower devices can delay overall model updates. Inconsistent data quality and availability across different devices. 3. Privacy risks. Although data isn't shared directly, clever attackers may infer sensitive info from model updates. Gradient leakage attacks can reconstruct private data, requires additional techniques like differential privacy or secure aggregation. 4. Aggregation complexity. Fairly combining model updates from many different sources is technically difficult. Some updates may be noisy or corrupted, affecting performance. Requires smart algorithms to ensure fairness and accuracy in model merging. Applications of federated learning. 1. Healthcare hospitals can train machine learning models on local patient data like medical scans or records without ever sharing the actual data. This protects patient privacy and helps hospitals comply with regulations like HIPAA while still benefiting from shared model improvements across institutions. 2. Finance and fraud. Detection banks can build fraud detection models by training locally on their own transaction data. They then share only the model updates, not the sensitive financial data itself. This allows different financial institutions to collaborate securely and detect fraud more effectively across the industry. 3. Mobile keyboards apps like Gboard or SwiftKey use federated learning to personalize predictive text suggestions by training on what you type locally on your phone. This helps improve accuracy while ensuring your private messages and typing habits are never uploaded to servers. 4. IoT devices. Smart home devices like thermostats or speakers can learn from your behavior locally, e.g., your temperature preferences or music choices. With federated learning, they update models without uploading your personal usage data, ensuring better privacy. Federated learning in distributed ecosystem. 1. Cloud and edge synergy. With the growth of 5G and edge computing, federated learning enables real-time model updates and faster coordination between devices and cloud infrastructure. 2. Infrastructure management. Federated learning supports efficient resource allocation. By distributing workload across devices, it reduces strain on centralized servers and makes large-scale deployment more practical and sustainable. 3. Hybrid architectures. Combining centralized and decentralized approaches leads to hybrid systems that balance scalability, efficiency, and privacy. 2. Infrastructure management. Federated learning supports efficient resource allocation. By distributing workload across devices, it reduces strain on centralized servers and makes large-scale deployment more practical and sustainable. 3. Hybrid architectures. Combining centralized and decentralized approaches leads to hybrid systems that balance scalability, efficiency, and privacy. Conclusion. Key takeaways. Federated learning decentralizes model training. It prioritizes privacy, scalability, and efficiency. It has immense potential across industries. If you care about data privacy but still want to leverage AI, federated learning is for you. If you found this video helpful and you're looking for someone to build something similar for you or your business, whether it's automating repetitive tasks, building custom web tools, dashboards, AI-based tools, or data workflows, I can help. I offer custom development services, including web automation, API integrations, Python scripting, Django apps, Python-based solutions, AI-based apps, and more, all tailored to your exact needs. Whether you're a small business owner, a real estate agent, or a busy team looking to streamline operations, let's talk. Check the link in the description to get in touch or book a quick call with me. Let's turn your idea into a working solution. Thanks for watching. And if you haven't already, don't forget to like, subscribe, and hit the bell so you don't miss more smart tools and tutorials.